This is section 1.4 in college algebra. We're going to talk about the different types of functions first. And so for right now in the course, we've got three different distinctions. A constant function is f of x equals b, or y equals some number. Example, y equals 3, or f of x equals -5. That is just a horizontal line. Then we have linear. Linear is f of x equals ax plus b, and most of us are used to hearing y equals mx plus b. That's the slope-intercept form. So you're kind of familiar with that. Here's a couple of examples. And then for now, everything else we're going to throw into the category of nonlinear. And we'll get to lots of different things as we go through the course. But right now, if we are asked to say what kind is it, those are our three choices. So again, here's an example. F of x equals -4x plus 6. That is linear. 3x squared minus 2. That goes in the nonlinear. F of x equals 5. That's a constant function. So that is that. Now let's talk a minute about increasing and decreasing functions. So when you're talking about whether a function is increasing, you look at it from left to right, and is it going up? That's increasing. That makes sense. If you're going from left to right and it's falling, then it's decreasing. In some things, it could be doing both. From -1/2 to 0, this is decreasing. From 0 to 2, or not -1/2, from -2, and then over here on this side, it is increasing. So we need to know what it means when I say where is a function increasing, where is it decreasing. You're looking at the x values, and you don't worry about how high it's going on the y or anything else. From this x to this x, it is decreasing. From this x to this x, it's increasing. And in this section, we again have some things asking for interval notation, some for inequality. Chart for reference. All right, now we need to talk about slope. Most of us have done slope. We started doing that back in middle school probably. Slope is the average rate of change. How does y change with regard to how x is changing? The formula is m is our slope, equals y2 minus y1 over x2 minus x1. And that's how we will figure that one out. Now we're also going to talk about the difference quotient. It is the slope of a secant line. It's often used in calculus to calculate rates of change, but these are instantaneous rates of change. So you can't find the slope of a curve without calculus. So this is just a touching on that, and we won't do anything very hard on it. But here is the formula for the difference quotient for u. So if we have 2 points on a line, we don't know what the x's are. So we have an x, comma, f of x, and then if we move h units to the right, now we're at another point. So could we agree that this x has become x plus h? This y is f of x. This y is f of x plus h. So we've just named these points knowing that we changed some difference of h. So now it's y2 minus y1 over x2 minus x1. Well, what happens down here? The x's are going to cancel out. And so there's our formula. We're left with h on the bottom. That formula is on the yellow packet as a handout. On the handout, it's on the first page. And this is what we're going to use for the difference quotient. Now, we're going to go through an example and the steps to do that. So if you have f of x equals 8x plus 5, and it says find the difference quotient. So first of all, you need to find what is f of x plus h, because that's this piece of the formula. So remember how we plug this in to our x part? That's what it means when we do f of that. So I've got 8x plus 8h plus 5. That's my yellow part in the formula. My f of x is the original. So now I'm ready to put everything in the formula. So I've got f of x f of x plus h minus f of x. And I would always suggest to put this part in parentheses to remind you to change signs. And that's all over h. Well, when we remove these parentheses, we have a minus 8x and a minus 5. Well, look, the minus 5 and the plus 5, those cancel. The minus 8x and the positive 8x, those cancel out. Top to bottom, the h's cancel, and we are left with 8. 8 is the difference quotient. Now, if you are taking the difference quotient of a linear function, it's going to be the slope of the line. And we know this right here is the slope. So you knew what the answer was before you started. But if the question says show your work, this is the work that must be shown. So keep that in mind. You may have to show work, and that is what we have here. So that is the note that I think will get you ready for the problems for 1.4. So let's go look at the problems. So here are our problems from 1.4. Number 1, a linear function f can be written in the form f of x equals mx plus b. Identify m and b. Pretty easy. So m is 20, that's that part, and a negative 10 is your b. Remember, b is your y-intercept, m is your slope. Same question number 2. Now we don't have a plus and a number here, so our y-intercept, our b, is 0. M is negative 6. Number 3, find the slope of the line that goes through these points. So I like to always start on the right. That's going to be my y2s and my x2s. You could start this way as long as you're consistent, but you'll notice that I do the other. So I have 6 minus 2 over 6 minus 4, which gives me 4 over 2 reduces to 2. So the slope is 2. Do that again for number 4. 2 minus 2 over negative 8 minus 1 is 0 over negative 9. As long as your 0 is on the top here, your answer is 0. If you get a 0 down here, it's going to be undefined. Number 5. Find the slope, if it exists, of the line with these points. And these are decimals. So we've got 0.3 minus 0.4 over 0.1 I think I have that backwards. Hold on, let me fix that. I had it right. I don't know why I looked at it wrong when I was saying it, but it was right. So 0.3 minus 0.4 over 0.1 minus a negative 0.3. That gives us negative 0.1 on the top and 0.4 on the bottom. That is the same as negative 1/4, and they do want it in either in a whole number, integer, or a simplified fraction. They don't want any decimals. So we've got negative 1/4. Number 6. Okay, we've got negative 8 minus a negative 7 over 3 minus 3. That gives us negative 1 over 0, and remember what we said, if you get 0 on the bottom, it is undefined. You can't divide by 0. So slope is undefined would be your answer. Number 7, all right, we're back to looking at a line equation. F of x equals negative 8x minus 3. The slope is negative 8. And so what that's saying, since the slope of the graph is negative, as x increases, f of x decreases. For every 1 unit increase in x, there is a decrease of 8 units here. Now you want to remember, you're not going to put a negative 8 here because this word decrease takes care of that. So it's a decrease of 8 units. All right, number 8. The slope of this is negative 5/6. That's a negative slope, so we're not going to be rising. We are going to be falling 5/6 unit for every unit increase in x. Number 9. What is the slope of this? Now this says 4 plus x. It's just written a little bit backwards for us. We don't have the x at the beginning, but the number in front of x is 1. So the slope is 1, and there's an increase of 1 unit every time in f of x. State the slope of this one. All right, this is one of those constant functions. There is no x term. In a constant function, the slope of a horizontal line is always 0. If the graph has a slope of 0, it is a horizontal line. Number 11. The graph shows the cost of buying X square yards of carpet. Find the slope and interpret it. All right, so they didn't give us anything, and you could pick any 2 points that you want. I definitely want to pick something where the squares intersect. So I just picked here and said that point is 660. This point is 440. Then I used my slope formula, 60 minus 40 over 6 minus 4. That's equal to 20 over 2, which is equal to 10. So 10 is my answer for the first part. What does that represent? Remember, slope is a rate, so it's always going to be something per something. And so we're talking about carpet square yards and the cost in dollars. We don't know anything about installation per hour of install. We don't have any of that. The cost of installation, no. Size of the carpet, no. Total cost, no. But this says the cost per square yard of carpet. Cost per square yard. So that is that one. Number 12. Winning times for the 200-meter dash can be approximated by. We've got this where X is the year. So right there, that X. What is the slope? Well, the slope is this number here, so negative 0.06568. Interpret that. Well, it is decreasing. The winning time is decreasing by that number seconds. The decrease takes care of our negative, remember? Over a 4-year period, what are the winning times expected to do? Well, we'll multiply, because X is here, we'll multiply 4 by that, and we get negative 0.26272. That negative, we'll use the word decrease by that many seconds. So be careful to watch that when you're choosing your answer. Number 13, determine if this is linear or nonlinear and if it's a constant function. All right, so the absolute value is a nonlinear thing. That's our category now. So we know it's a V. And you could graph that in your calculator. What I will tell you is if there's a negative outside right here, then that V is going to be upside down. If there's not a negative here, this is going to be it. We know this is not the graph. That's a straight line. That's a linear. Here's our V for absolute value. Number 14, x squared plus 4. We know that that's a parabola. Goes in the nonlinear category. And this is not a parabola. This is not a parabola. So by elimination, we could get this. Or we could graph it in our calculator and check that. All right, let's look at 15 and 16. Let's see, let's get 15 here. So number 15, the graph of a linear function is shown. Identify the slope, the y-intercept, and x-intercept. Write a formula for f, estimate the 0 of f. The 0 is where it crosses the x-axis. So if we're looking at this, we can find the y-intercept. It's right down here where it crosses, so that is at 7. So we know that one, negative 7. The x-intercept is up here. It is a little more than 3. So let's see if we could figure that out. So since we know that this is the y-intercept, if we go up to and over 1, we're at another point on the line, and so that is up to over 1. That is a slope of 2. So we can say our slope is 2 and our y-intercept is 0, negative 7. Now, we've got our slope, we got our y-intercept, so this is a formula for f. If we want to find the x-intercept occurs when y is 0. So we're gonna write that out. So we're gonna have 0 equals 2x minus 7. I'm gonna add 7 to the other side, and I have 7 equals 2x. And then I'm going to divide by the 2, and I have 7 halves equals x. That's going to give me my x-intercept. And so I can write that. I write both of those as ordered pairs here. So y-intercept is 0, negative 7. X-intercept is 7 halves, comma, 0. And the 0, which the other word for that is x-intercept or solution, that is 7 halves. So that's how we can get that. Number 16, use the graph to determine the intervals on which this thing is increasing. Well, it starts here at x equals 3. And remember, we don't worry about the y, but from 3, it's going to just keep going this way. So from 3 to infinity, it is increasing. Where is it decreasing? It's never decreasing. All right. The following table lists remaining life expectancy E in years for females of age X. So if we want to find the slope, we can just pick 2 of these points. And let's do the first 2. So I've got 27 minus 35.3. So I have 27 minus 35.3 over 60 minus 50. When you do that, average rate of change is negative 0.8